This is 2025 paper 2 question 9, and we're given this tree diagram and told to fill it in. So we have the whole population, and 6.7% of them have diabetes. So how many of them don't have diabetes? Well, the entire population is going to be 1, so we can do 1 minus 0.067, and we'll get 0.933. So that's what goes in that box down there. So we get 0.933. And then we can just look at those who have diabetes. So if they have diabetes, the probability that they have the correct result is 99%. So you have diabetes, and then the probability that they test positive is 0.99, which means that this one down here is going to be 0.01. Because if there's a 99% chance that they test positive, that means there's a 1% chance that they test negative. And we can actually check this. If we take this number here, and we multiply it by this number here, we should get this number here, which you can verify is true. And then when we multiply this number by this number, and we round it to 4 decimal places, we'll get 0.0007 as our answer. Then if they don't have diabetes, the probability that they get an incorrect positive result is 7.8%, so that's down here. So then the probability that they do get that they get a negative result is just going to be 1 minus this number, because either they have to test positive or negative. There's no other option, so it's going to be 1 minus the probability that they test positive. And that'll give you 0.922. And then we basically just multiply those probabilities together to get the last thing, and then we add all these up, and we can check that this is all equal to 1, which makes sense, because obviously anybody from the population has to fall into one of these 4 categories, so they should all add up to 1. Then we're told to use this diagram to answer some questions. So find the probability that a person picked at random tests positive. So there's 2 ways to test positive, either here or here, and the reason there's 2 different ways is because there could be a real positive or a false positive, so you just have to add those 2 numbers together. And when you add those 2 probabilities together, you get 0.1391. Again, 4 decimal places where it says. Then we're told, so this person tests positive for diabetes, same as before. Find the probability that they actually have diabetes. So this is the probability that they get a positive test. The probability that they actually have diabetes is this. So basically out of, so division means out of. So out of all the ways that they could test positive, this is the probability that it's a real positive. So we divide those 2 numbers, and what we get as our answer is 0.4766 when you round to 4 decimal places. Then we're told 5 people are picked. Assume that 6.7% of them have diabetes. What's the probability that 2 or more of the 5 of these people have diabetes? So basically, 0.067 is the probability that they do. So 0.933 is the probability that they don't. So the probability that 2 or more, well, that's going to be 1 minus the probability that 1 has diabetes, minus the probability that 0 have diabetes. So 1 is all options, and then we're taking out the options where 1 person has diabetes and the options where 0 people have diabetes. So the way that we can do that is 1 minus, and then since we have 5 people, we're going to have 5 choose 1, and then 1 person having diabetes. So having diabetes is 0.067, so that's going to be the power of 1, and then we multiply that by how many people don't have diabetes, which would be 0.933. And that happens 4 times. And then we have minus 5 choose 0, which is just one way that nobody can have diabetes. And then we would have 0.067 to the power of 0, because nobody has diabetes, multiplied by 0.933 to the power of 5, because all 5 people don't have diabetes. And then when you put this all into your calculator and you compute it, you'll get 0.039171. And then again, 4 decimal places will have 0.0392 we will have, because 17 rounds up to 2. So that's our probability. Then we have 20 people taking part in a trial. 10 of them will be picked to be in group A, and then 10 will be in group B. How many different combinations of 10 people can be picked to be in group A? So I suppose the fastest way to do this is we have 20 people. How many different ways can we choose 10? You can just put 20 choose 10 into your calculator. And when you do that, you'll get 184756. Then we're told that 10 people are picked and they're put in group A. And then each person from group A is paired with somebody in group B. So there's 10 pairs. How many different sets of 10 pairs can be made? This is a bit vague because we're not told, is it just one fixed group A or is it for all possible groups A? So in the marking scheme, they accepted both. I'm going to assume it's just for one fixed group A. So if we have one fixed group A, we have 10 people, which I'll just draw out like this, 5, 6, 7, 8, 9, 10. And for each of them, we need to pair them up with well, there's one person from the other group. So let's just take this first person. How many different people could we pair them up with? Well, we could pair this guy up with 10 different people. Then for each of the 10 people that he could be paired up with, there are 9 people that the second person can be paired up with, because one of these people we don't know who it is. Could be any of the 10, but one of them is crossed off. So that leaves us for each of those 10 different options. There's 9 different options for the second person, and by the same logic, 8 and 7 for the next person. So the answer is a 10 factorial, which is this big number. So that's for any fixed group of A, but then obviously this is how many different options we have for groups A. So we have 184,000 different possible groups A, and for each of those groups, this is the amount of pairs that can be made. So if you want to find the total number of pairings for all groups A, you multiply these two numbers together, but the marking scheme accepted this or this times this, because it was a bit vague. Then in part D, we're given kind of a similar setup, and it's equally as vague. So again, each person in group X paired with 2 people in group Y, how many different sets of such pairings can be made? It doesn't say for every single group X or just for a particular group X. So I'm going to assume there's a particular group X, but again, the marking scheme accepted both. And all you have to do is, if you wanted to get the total number, is what I'm doing here is just for one group X, you just multiply that by how many groups X there are. And the number of different groups X there are is 24, choose 8, because there's 24 people in total. How many different ones can we choose? 8. That's how many different possible groups of X there are. And now we're going to figure out how many different pairings can we make once we have a group X. So we'll use the same kind of logic again. So let's take this first person here, and let's see how many different options do we have. Well, we have 16 people to choose with, but then we have to pair them with a second person, so then we have 15 options. However, we have to be careful, because this 16 times the 15 is kind of like a unique. So for example, the 16 times the 15, so the first person could be this, and the second person could be this, right? Because we have 16 options and 15 options, but equally, we could have the first person to be that dot on the right. So equally, we could also have the first person we choose to be this guy, and the second person we choose to be this guy. But they're, for our purposes, they're the same kind of option. It doesn't matter what order they're chosen in. So because we have two things, and the order that they're chosen in doesn't matter, we divide this by 2 factorial, or just 2, because there's 2 different, I suppose, there's 2 different copies that we could have. So we divide that by 2. And then for each of those options, for the second person, now we have 14 options and 13, because again, we only have these people to choose from now, or we only have 14 people to choose from, and then 13 people to choose from. And then again, there's going to be duplicates, so we divide this by 2, because we can always swap them around. And then we just do the same here. We'll have 12 by 11 divided by 2. So in total, what we get, you see this is 16 factorial, but then we're dividing by 2 how many times? Well, you can see we're going to divide by 2 8 times for each person. So 16 factorial over 2 to the power of 8, which will give you, they'll give you this very big number when you round to 3 decimal places. And then, so this is assuming we already have a group X. How many different pairings can we make? If you wanted to see for all groups X, well then we have 24, choose 8 different ways we can make a group X of 8 people. And then we multiply that by, for each group, there are this many different pairings. And that gives you an even bigger number, but both were accepted because the question was a bit vague.